there is a lot of questionable research out there that really deserves to be looked up again at. And you really need to look at who were the authors, who funded it, where was it published, who was the editors of that journal. I mean, there's just so many pieces involved in that puzzle.
The Rational View is a weekly series hosted by me, Dr. Alan Scott, providing a rational, evidence-based perspective on important societal issues.
Produced by Soapbox Media.
The world needs evidence-based public policy now more than ever. Making the right decisions should not be partisan politics. Please help spread The Rational View by going to patron.podbean.com/The Rational View. Together, we can make a better future. Hello, and welcome to another episode of The Rational View. I'm your host, Dr. Al Scott. This episode is based on feedback from a listener who suggested I investigate the science of Deutenomics. I don't know if you ever heard of that. I certainly hadn't. Deutenomics is looking at the impact of heavy water on health. Apparently, it's a thing. Is it a snake oil or is it real? Deuterium is an isotope of hydrogen. An isotope is something that has the same number of protons, but a different number of neutrons. So the mass is different. And hydrogen is typically just a proton. Deuterium has a proton and a neutron. So it's twice as heavy as hydrogen, as normal hydrogen. Chemically, it should react identical because it has the same number of electrons. And electrons are what conforms your chemical character. But the reaction dynamics can be significantly different due to the big ratio of mass 2-to-1 of deuterium versus hydrogen. I found an expert on the subject to chat with. This will be interesting. This is a job for The Rational View. If you like what you're hearing, please press like on your podcast app. I'd love to hear you. Come give me your opinions and ideas for new podcast episodes on my Facebook group, The Rational View. Dr. Petra Davelaar is a naturopathic doctor who specializes in Deutenomics. Deutenomics is a new area in science that explores how hydrogen moves through water and other intermediates outside our body. Essentially, humans are electric beings of water fueled by light. Deutenomics seeks to uncover the biochemical and quantum physics of these processes. She completed her naturopathic medical training at Bastyr University and is certified in functional medicine and nutrition. She's an invited reviewer for several scientific periodicals, including Scientific Reports, a Nature Group research journal, as well as Medical Oncology, a Springer journal. Dr. Davelaar, welcome to The Rational View.
Thank you so much, Al. I really appreciate your interest in Deutenomics.
Could you give us all just a feeling of your background and how you got into naturopathy and then into Deutenomics? What was your pathway and why did you go that way?
Yeah, very interesting. So I did a lot of things over time. I actually got to medicine at later stages of my life. I grew up in the Netherlands. I'm Dutch, and I lived there for my first 21 years. Then I moved to New York and in New York City and lived there for 5, then 20 years outside of that. I worked in music, in television, Saturday Night Live for a few years. I did some fun stuff.
You were on Saturday Night Live?
Well, I was I was not on it. I was part of the backroom staff. But
cool.
Yeah, it was actually really fun. It's a very New York experience, back then in 1990. Mm-hmm. And then became a mom and really shifted my interest into wellness and why we do the things we do in medicine and nutrition and so forth. And that kind of triggered this educational process of becoming a naturopathic doctor. I was looking at all the different programs that were out there that were of interest in me. And truly, I didn't want to just be a nutritionist, and I also didn't want to be a medical doctor because I knew I wouldn't practice according to their standards, and that will then, most likely you lose your license if you don't do that. So I figured, well, I'm just going to follow my heart and practice and learn to be able to practice the medicine that I'm very interested in, which is natural medicine. And so,
could you tell me a little bit more about that choice, about, the medical doctor versus the naturopathic doctor? What pushed you one way or the other? What was behind that?
Well, because in general, the standard of care or the conventional medicine uses primarily pharmaceuticals to manage people's symptoms, and they don't actually address the underlying core issues or lifestyle, none of that. And I am very keen on using medicine and natural medicine, so plants, botanicals, food, light, all of these that are crucial for our well-being. And that's not really something that you can do. So I had a good friend who went to medical school, and he did his first 3 years. And we talked about it at length at that time. And he said, well, listen, if you're going to go that route, you do understand that you have to shut up for 8 years, and you cannot, speak your truth in the whole program, because you will just be kicked out, or they'll make it miserable for you. So I thought, okay, well, I don't want that. So I went the other direction. Does that make sense?
Yeah, no. And as the rational view, typically we're interested in evidence-based procedures. So naturopathics don't usually come up as subjects of the rational view. How do you feel about that impression of naturopathy as not real science or not based on evidence?
Well, this is a great topic you bring up, because let's just talk about what we mean when we talk about evidence-based medicine, and what is that evidence, and how was that evidence created, and who paid for it, and what were they selling when they were creating that evidence. And if you have looked at the ability of studies to be repeated, or look actually at the clinical usefulness of most meta-analyses and so forth, it's really non-existent. So there are actually some very interesting papers that have been written about natural medicine, about plant-based interventions that can be extremely useful, but they're always small, because no one's paying for that. And it comes from tradition from many old healers and practitioners, Chinese medicine and so forth. And there have been some beautiful books written with excellent information and great details of all the constituents in plants. And the beauty of plants is, of course, that they come with all of its cofactors for them to work. And, what pharmaceutical industry does, it takes one of those constituents out of a plant with hundreds, and then gives a massive amount of that one piece, completely ignoring the fact that maybe those cofactors actually had a role to play and contributed to the properties and the effects of the plant. So, it's really complex. And I think there's serious issues with the current state of research and the decisions that we make based on what we are being faced. I don't know if you saw this recent Harvard huge scandal where dozens of papers have been falsified by the top administration of Harvard, and it's all just fake information. So this is Harvard. So that's evidence-based medicine. Mm-hmm.
Yeah, I mean, there are certainly bad actors in all fields that we have to be on the lookout for.
Yeah.
But in general, how do you feel about the methods of science whereby you have to have data to back up claims of efficacy? You have to have, statistical reproducible data. I mean, this is the idea of science, and maybe the practice of science isn't always perfect, but it ends up being self-correcting in the long run. How do you feel about that postulate, I guess.
Oh, I totally agree with that. I think it should be handled that way. Absolutely. But I think most of it is fraudulent or, skewed. Let's put it that way.
Okay. Well, that's quite a strong claim. I think most of the people working in science are actually quite good people.
Well, okay, I may be overstating that, but I think there is a lot of questionable research out there that really deserves to be looked up again at, and you really need to look at who were the authors, who funded it, where was it published, who was the editors of that journal. I mean, there's just so many pieces involved in that puzzle.
Yeah, there certainly are a lot of issues with ensuring that the proper research gets funded, and if the direction of research is driven by certain biases, that we should definitely look at those biases and challenge them.
Yeah. The problem is we can't make money off natural interventions, right? So that's why these types of studies are not done, and not enough of them anyway.
Yeah, well, some people do make a lot of money off of selling natural products.
That's true. That's true.
But let's get on to the topic of this, which is what really got me interested in your work, is Deutenomics. So Deutenomics, from what I've researched, postulates that deuterium in water, heavy water, is messing up our metabolism and contributing to chronic disease.
Yeah.
Now, deuterium, for everyone, is a naturally occurring isotope of hydrogen, and it appears about 150 parts per million in drinking water. So can you maybe give us your overview of what Deutenomics means and why it's important?
Yeah. So, as you said, deuterium is the stable isotope of hydrogen, and it is twice as large as a hydrogen atom, and it has twice the weight. And so any molecule that hydrogen and deuterium combines it becomes semi-heavy water, basically. It's very unusual to have two deuterium attached to an oxygen. But it changes the properties of any molecule that's part of. So the foods we eat is actually one of the most important pieces of this. And the deuterium content of foods vary greatly. It is the quality of the hydrogens and the lack of deuterium in that food that actually fuels our mitochondria and determines the quality and the quantity of your own deuterium depleted metabolic water that you create in mitochondria.
Okay, before we move on, let's define a lot of these terms, because this is new to a lot of people. So what's metabolic water?
Yeah. So actually there's three important aspects to the functions of mitochondria, and the main ones. And the first one would be the production of ATP that we're all familiar with. The other one is the production of heat. And then the third one is the production of deuterium depleted metabolic water. Most people don't know that we produce our own metabolic water. And this water is very special because if it's low of deuterium, it allows for cellular function to be optimal. And if we were getting a lot of deuterium into our bodies, this is where things start backing up. And once deuterium is at too high of the levels and it enters into the mitochondrial matrix, it will try to get out through to the via the ATP synthase. And if, because of its size, it will destroy these very delicate nanomotors that spin at 9,000 rotations per minute. And that then jams it up and mitochondria break down.
So let's dig into this a little bit more, because this is interesting.
Yeah.
Now, a lot of people, I certainly didn't know that mitochondria have processes that remove deuterium from the water. So how does it remove deuterium from the water?
So this is basically all the biochemical pathways that you may have heard of, glycolysis and the TCA cycle. They're there to prevent deuterium from entering mitochondria. So glycolysis has all these reactions, and the isomerase reactions actually remove very specific hydrogens upon a structure with if it's a deuteron attached to it, it will exchange that with hydrogen from the cytoplasm. And so all of those reactions are there to prevent deuterium from entering the mitochondria. And then the TCA cycle itself has all these water exchange reactions. There's 4 places where this happens. And again, the goal is to prevent deuterium from entering. So the matrix. And so that's key to it. This is how our body does that. And then there's many other pathways as well, but these are the main ones that we talk about and discuss and are clear.
And so this is a process of taking carbohydrates or taking sugars and breaking them down, basically, and then but there's actually isotopic specific reactions that happen in the mitochondria, which is you don't expect this. At first glance, you expect most chemistry to proceed independent of the isotopic composition of the compounds, but because deuterium has much stronger bonds because of its mass than hydrogen, it can actually be selectable in certain reactions. And I wasn't aware of this. And why would this come about? Evolutionarily speaking, why do mitochondria isolate deuterium? And what I found looking at the literature is that actually the presence of deuterium interferes with cell division in DNA, for example. If you get deuterium, the sort of hydrogen bonds are much stronger than in your heavy water than in regular water, and it interferes with cell division. And you can drink heavy water and it's not going to kill you right away, but it's going to interfere with cell division. In fact, I was looking it up the other day, and it was something like you have to replace 25% of the water in your body with heavy water before it's going to stop you from reproducing. But you go much beyond that, and it'll actually kill you because your cells will just all stop splitting at some point. So I think the question of the science of Deuteronomics is at what point does this become a problem for health? So maybe you could go into that a little bit.
Yeah. So once deuterium starts collecting and into the cellular structures, it actually forces cell division. And that's why it is also known as an oncoisotope, because of its size. And it also causes irregular amounts of chromosomes. And this is that whole process that causes this transformation to cancer. Does that make sense? Is that what you've been reading about as well? Or
I did hear something like that the deuterium interferes with DNA replication and mitosis in some ways, and part of that is multiple chromosomes. Yeah,
it drives cell division. It causes exactly that. So exactly what that point is, we don't know, but a good guess is that we're trying to keep the level of deuterium in our bodies at about 130 parts per million or below, slightly below, around that area. If you go too high, you're not able to excrete the excess levels efficiently through either too much is coming in, or you're not sleeping well, there's too much stress, or you're not getting enough sunlight, you're not moving enough, you're not getting enough oxygen, breathing right. All of these pieces play a role. And then it starts collecting into your tissues. And if there's a certain threshold reached, it can cause any form of mitochondrial dysfunction. So it's not just cancer, but it can also contribute to the the diabetes epidemic that we see. It can contribute to cardiovascular disease, neurodegeneration, all chronic issues that we're seeing currently in the world are as a result of this accumulation, or what we call decumulation, of excess deuterium coming in from food and environment.
That's a strong claim. Is there statistical evidence to back up the link between deuterium and chronic illness?
Yeah, there is. There's papers published on it. I have them all listed on my website, and I refer you to that. But yes, there is. Mm-hmm.
From my research, and there are review papers out there, very recent review papers actually,
mm-hmm.
on this topic. And there was a paper published a year ago in the International Journal of Molecular Science entitled Emerging Role of Deuterium-Protium Disbalance in Cell Cycle and Apoptosis. So that's a big mouthful and a lot of confusing words. Cell cycle is your cell's living cycle,
Yep.
and apoptosis is programmed cell death, which is
Yep.
very important in regulating cancer.
Yep.
Effectively, when cells mess up their DNA, they're programmed to kill themselves. And cancer is when that apoptosis is screwed up, the cells don't kill themselves and they reproduce without end. And apparently there is some emerging evidence that deuterium depleted water activates apoptosis in malignant cells. So it actually causes cancer cells to kill themselves.
Mm-hmm. Mm-hmm.
And this is backed up with a few small studies. So this is very interesting, breaking
mm-hmm.
scientific news. As far as I was completely unaware of this.
Yeah.
And it also has the reverse function in healthy cells, in that it doesn't kill them. It actually reduces DNA damage and free radical production in normal tissues. So that was totally unexpected to me. I was, as a scientist, I'm very skeptical of new and strong claims. So I'm always looking for debunking of Deutenomics. And really, I don't think there is any debunking of this yet. We're still in the exploratory stage of what this actually could be doing. But the initial research that I found seems actually to support the fact that this works against cancer.
Mm-hmm.
So that's very interesting.
I mean, there's decades of research, honestly, Al, and I want to, let's step back for a second. So I want to explain first. So Deutenomics was coined by Dr. Laszlo Boros in 2019 at the Budapest Conference of Deuterium Depletion, and that was organized by Gábor Shumiai, and he, in fact, in 1990 wrote his first book about deuterium depletion. In 2015, it was published, I think, in 2016, the submolecular regulation of mitochondria. That was the paper that was published by Dr. Boros and colleagues, including Gábor Shumiai. And that really was the first paper that very precisely described the exact mechanisms by which our bodies deplete deuterium, and that is that process of the TCA cycle as well as glycolysis. So it's perfectly detailed in there. And in that paper, they very much connect this dysfunction to all chronic disease. So I encourage you to look at that. But truly, in 1990 was the first paper that really that was a study done by Gábor Shumiai, and that first introduced this whole concept of that deuterium is the factor that causes the cellular division to happen, and so there have been many papers published since. There are new ones coming out. There's actually a couple of them that are fascinating that are currently in the final stages of peer review, and I look forward for you to send those to you so you can catch up on that, because every paper is better and gets more detailed and better understanding of how all of these mechanisms are. This is a new science, as you have discovered, and there is much still to be specifically detailed and figured out. So really, what you can think of as deuterium, it is important as a structural component, but it destroys moving proteins. So we need deuterium for connective tissue. It's very important for bone and any connective tissue, really.
Really, that's interesting.
Yeah, but moving proteins, it can destroy it. So it would it'll
affect how they fold. The proteins fold, and it can affect the activity of their active sites because it's got a different bond strength than regular hydrogen.
Right. So the strength to break a bond from deuterium and carbon is between 7 to 15 times as difficult to break. So, okay, if we want to relate that down, for instance, to cholesterol, let's say that. So that's 27 carbons, 44 hydrogens. What happens is if the sunshine, the UVB, shines on your skin, and then it starts resonating the hydrogen bonds that are attached to the carbons, and that at the right amount, it will open up the bonds between carbon 9 and 10, and you get the cyclosteroid or vitamin D, the precursor. So that won't happen if there's a deuterium atom attached, neutron attached to that particular carbon structure, and then you will not. So that's one way, for instance, you can think about it. It's the same for any sugars that are made up for the DNA backbone. And if there are deuterons attached to it, the shape will be different of the DNA. And so we're not just talking about the genetic information, but we're also talking about that structure then. And that alone can cause these epigenetic expression that, you can't measure for, but it's there because of the deuterium. So those are some
You
examples.
mentioned something earlier about food having differing levels of deuterium. Now, that is something that was unexpected to me. How does food have differing levels of deuterium in it?
Well, because it contains water, lots of and hydrogen, right? Ultimately, that's what it comes down to. So out of all of the major food groups, fats, carbohydrates, and proteins, the fats actually have the lowest deuterium content. So this is the power of the ketogenic diet. This is why that works.
So why though? Why do fats have low deuterium content?
It's these structures of carbons with hydrogens attached to it. And
but it's because it's biologically created in other animals that have the same mitochondrial processes that are taking deuterium out of the structures. The ATP is depleted in deuterium.
As long as they were fed a authentic diet and lived in their, supposed habitat. So animals that are grown in, these giant feeding structures and never go outside and get grains, the composition of their fatty acids in that of the foods that they produce, whether it's the protein or the dairy that comes from them, is higher in deuterium than those from grass-fed animals. That's been published in 2022. It's a great paper. So that makes a difference. So let's just go over that. So fats are the lowest. Then you have animal proteins, again, as long as they were naturally raised and with respect to their heritage. Then green vegetables, because of the process of photosynthesis, that's always also a depleting mechanism. And then you kind of start hitting right around the 150 ppm, which is what most drinking water is. And that depends on where you go and whether it's spring water from high up the mountains and so forth. But for most of us, It's about 150 ppm. So fruits then come in and they are higher in deuterium, and then grains as well. And then depending on how foods are produced in the level of processing that takes place and the kind of fatty acids that are in them, they start going up in deuterium content. And GMO makes a difference. That's kind of how the whole progression
I can understand the difference between animal-created proteins and animal-created fats from, say, laboratory process, which is not fractionating D2O out of the incoming products. I could see that there would be a difference in deuterium content between like an artificial fat, like margarine, for example, versus butter. I could see that if you have these biological processes that are fractionating deuterium, that seems to make sense. I'm not really clear on the natural versus in a barn impacts on how deuterium gets fractionated differently in those cases, or grass-fed versus grain-fed. Is that the source of the difference?
That's exactly right. Yeah. So if a grass-fed animal that lives outside becomes a different food for you because of its makeup, because you eat what they ate. That's basically how that goes. So grain-fed animals tend to fatten further. The balance shifts between omega-6s and omega-3s. And that's why an omega-3 is different for us. The saturated fat content is changes, and that's ultimately what makes the quality of and the level of deuterium of those animals different.
Mm-hmm. So there's some evidence emerging that deuterium plays an important role in health. Do people are people suggesting that we should be drinking deuterium depleted water instead of tap water? Is that something that is recommended for health?
Well, it depends. I think the primary way to address this is with food. If you are in a health crisis and if you've, for instance, received a cancer diagnosis, it may be very beneficial for you to try and drastically and quickly drop your deuterium level. And in that case, yeah, it would make sense to drink deuterium depleted water for a period of time. Yeah.
Is that something that is available commercially? Can you get deuterium depleted water? And if so, is it really deuterium depleted or is it snake oil?
Well, the companies that I know that produce it is really deuterium depleted, and that has been tested by analytical third-party labs, and that gets tested all the time. Every batch that is made, for instance, by Clarivia and Lightwater, is tested for their deuterium content, and they have the paperwork on that. So yeah. I
can see an industry here working with the CANDU nuclear reactors to remove deuterium from the water to support the nuclear reactors, and also develop deuterium depleted water as a byproduct.
Yep, that's exactly right. And there's been whole batches of that released on the market under certain names, and that's questionable, right? But yeah, so this water is depleted. You can also try and get optimal spring water that is generally lower in deuterium levels as well. That, however, is not therapeutic. We really think of a water that's around 125 parts per million is a wellness water. And to actually achieve therapeutic benefit, you need to go to as low as 105 or 85 or 65 and so forth. Generally, the water is being sold in even lower concentration at 10 ppm or 25 ppm. And that's done because it's so expensive to ship, of course, and it makes more sense to have a a lower concentrate that you can then dilute with another quality water and drink the desired amount.
I read one paper that was looking at the impacts of drinking deuterium depleted water and drinking deuterium enhanced water, and it showed that in both cases it actually stimulated the thyroid over the first couple weeks, and a lot of it was due to just the gradient of deuterated versus non-deuterated in the cells versus the blood was causing changes in how cells operated, and at a certain point it was causing inflammation, just the difference. And like it was, I think the researchers said that the first 14 days had a stimulating effect, but then it dropped off significantly after that. So obviously an area that you might want to be careful about doing it for long periods of time. Is there any evidence that it's good over long periods of time, or is it just something you'd want to do over a short term?
The best evidence and the long-term evidence that we have comes from Dr. Chambier, and he has been cycling the water over periods of time. And so you take breaks and then you go on again. And it's also important to kind of change the ppm of the water that you use, so a system doesn't get used to just one particular ppm. And I think there's also a case to be made to not drop too steeply, because that has consequences and you will feel it. Going slow and going mindful makes the most sense. And it really also depends on your body weight. It depends on your amount that you consume, and what you want to achieve with why you would consume it. If you are really having a serious diagnosis that you are dealing with, then it's important that you get some guidance to figure out how to do that well and achieve the depletion rate that you really are trying to go after.
It's very, very interesting stuff. So you are, as a naturopath, are you prescribing this to your patients?
Yeah, in some of them I am. Yeah, I work with the entire, reach of interventions that we know will help regulate deuterium in the body. It's not just about depletion, but it's also about regulation, more so. But in some situations, you really need to deplete quite quickly. And, we've been fortunate to be able to measure some of the levels. And it's clear that the severity of some of the diagnoses and the presentations of the cancers correlates with the level of deuterium that the patients have in their system.
Yeah, no, and this is just for listeners, this is, I came into this expecting this not to be a thing. This is what I do as a scientist and a skeptic, is to be skeptical and look for debunking, and to be told by a naturopath that this is science, and this is actually proven, is often goes the other way, shall I say, in my research. But this time, I think there is a nugget of truth to this. And there are good scientific papers out there in reasonable journals that are showing that this is really, really having an impact on cancer. I think the association with chronic disease doesn't seem to be as strongly supported by the evidence, in my opinion. I don't know what's your opinion of the association between deuterium and chronic disease? There's
not a large breadth of papers published on that. You're absolutely right. But we know that the cause of most chronic disease is mitochondrial dysfunction. And so if you're logically deducing from the fact that that deuterium destroys or really significantly impacts mitochondrial function, then it's clear that you can make that connection.
Yeah. Very interesting stuff. So thank you so much for coming and chatting with us about Deutenomics. Is there any last words you'd like to share with listeners about this work, about what's coming up next, what we should be on the lookout for, or where we should go research if we want to learn more?
Yeah, there's some really great papers coming out soon. There's one particular that is about the importance of being in a ketogenic state when climbing Mount Everest. And that is because you facilitate the production of metabolic water, and you're able to recycle the oxygen in your tissues through peroxisome and mitochondrial crosstalk. And it's utterly fascinating. And this paper also, for the first time, discusses how the energy produced from the synthesis of the metabolic water is approximately 10 times that of ATP synthesis. So we're talking 280 kilojoules of energy versus about between 20 and 30 from ATP. So it's a very significant paper. It's a hypothesis, but the calculations were done, and this is what the data shows. And so it's a fascinating paper because it really explains so well the importance of regulating deuterium in the body in order to perform at high levels in all ways. So that's a really fun part.
Well, I'm looking forward to more research coming out on this topic and learning more about it. Everyone stay skeptical.
Yep, absolutely. Don't take my word for it.
Don't be fooled. Go look at it yourself.
Yeah, I agree. I totally agree.
For spending time and coming to chat with me, Petra, I'd love to send you a Rational View t-shirt if you'd like. So thank you so much.
Thank you. I look forward to that.
For coming on the show.
Okay, take care.
If you'd like to follow up with more in-depth discussions, please come find us on Facebook at The Rational View and join our discussion group. If you like what you're hearing, please consider visiting my Patreon page at patron.podbean.com/therationalview. Thanks for listening.